Good afternoon, everyone. Today I will demonstrate Raman spectroscopy. The aim of this instrument is to find out the composition of the material. You can identify the phase of a polymeric substance. You can find the crystallographic orientation of your material. Now I will describe the instrument parts and the softwares and the lasers, whatever is attached to the instrument step by step. So the system is from Horiba Scientific Instrumentation, and the model is the LabRAM HR evolution. So with our system, we have four sources with our system. So this one is the 325 nanometer laser. This one helium cadmium laser. This is the controller of the laser, and the laser is inside this box. Okay. And this one is the 532 nanometer laser. This is a diode laser, and the laser is inside the instrument. This one the third laser. This is 633 nanometer laser. This is helium neon laser, and this is the controller of the helium neon laser, and laser is inside the instrument. So this was the microscopic arrangement. We have four objective here. Sorry, 5 objective here. One is 10x, 20x, 50x, 100x, and 40x. Right, as you can see. This is 10x. This one 50x, 100x, 40x, right? And this one, you can see, this is the detector of this instrument. This is CCD detector. The working temperature of this detector is -60 degrees centigrade. So before starting an analysis, we have to come before 30 minutes of the analysis, and we have to switch on all the lasers and the detector to come to its working temperature. So firstly, we have to power on the main switch. All the power connection with the system is there, right? And this switch is for lasers, 4 lasers that we have with our system. So after power on the main switch, you have to switch on the main switch for the laser, right? Then this is the controller for the microscopic system. So after that, we need to switch on this, right? And one by one the lasers. So as I said, this one the controller for the 325 laser. So you have to first switch on this 325 laser, right? And this one for 532. By rotating this key, you can switch on the 532 nanometer laser, right? This is also like we have one key here. By rotating the key, you can switch on the 633 nanometer laser. Presently, we don't have the 785 nanometer laser that is in our company for repair, so we cannot see right now the 785 nanometer laser, right? After switching it on, you can see you have here indication of green light, right? So initially you will see it as green, as orange, until it reaches to its working temperature. The working temperature for this detector is -60 degrees centigrade. Whenever it came to -60 degree, then we will it became from orange to green, right? So after switching on all the lasers and detector, you will have to on the software. We have lab spec 6 software. Just double click the software and you will find this window, right? Here you can see that detector is now ready, but initially when we switch on the detector, it will turn it at orange. As I said here, it will become a green while it reaches to its working temperature, that is -60 degrees centigrade, right? What parameter we have to give? So here is acquisition parameter that we need, that mainly focus on this window. So here this is the spectra, means this will coming as per as the analysis is carried out. So firstly we need to give the range from where to where we will take our Raman spectra. So I am giving it as 100 centimeter inverse to 1000 centimeter inverse, right? This is the acquisition time. This is in second. Your scan speed of a sample is depend on this acquisition time. If you give less time, then it will perform rapidly, and as you increase the time, your scan will be slow and you will get more resolution data, right? This is the accumulation time that we need to give. Accumulation time 1 or 2 means it will acquire your data that number of time. Means if you give the accumulation time 1, then it will take 1 acquisition. If you give number 2, then double acquisition will be there, right? This RTD time you will need when you perform real time. Then you will need RTD time. Means you know the spectra of your samples. You will give the spectra here. Means if you know that your sample has a spectra in 521 nanometer, you just give it there, and by entering it will stay on 521. And we are selecting the objective 50x and the grating 800. What does grating do here? The grating is used for it disperses the wave number as its order, right? The filter we use for the intensity, to control the intensity of the laser. If you are giving 100%, means no filter is using, means 100% of your laser intensity is incident on the sample surface. And if you are decreasing, you are using 10%, means it only block 10%, and 90% of your filter is 90% of your laser is incident on the sample surface. And the laser we are using here is 633 nanometer, and the hole is using is 100. What is the hole? So during the analysis of Raman, as we know, the laser when incident on the sample surface, 2 type of scattering takes place. One is the elastic scattering, another one is the inelastic scattering. So elastic scattering basically is the relay scattering, as you say, and actually our Raman scattering is the inelastic scattering. So when sample analysis takes place, 2 type of scattering takes place. Then to discard the elastic scattering, means relay scattering, we need this hole to, means it's like a pre-filter that block the relay scattering, and only Raman scattering passes to the detector, right? And the range, we can give the range as UV or visible. When we perform the UV means with 40 means 325 nanometer laser, then we need to select that UV. Otherwise we can select visible, but we can always give it as auto, so it will select accordingly UV or visible, right? And this is the AFM part is connected with the system. When we perform some AFM analysis, then we will have to switch on this AFM. So after the detector and lasers are ready, we will perform one Raman analysis. 1 or 2 samples we can perform, right? Okay, so we have one standard sample. This is the silicon sample. So we'll perform our standard analysis first with this silicon sample, right? So this is the stage where we mount the sample. So firstly, and by this knob we can pull it up or down the stage, right? So firstly we will pull down the stage and mounting this sample to the stage, right? Clip it outside. Okay, then we will focus it through our microscope. For that we need to turn on this white light, right? Yeah, and you can see in the window in the software, 1 second. So I'm now focusing my samples. For that you can use these also, and by seeing the window of the software. So I am seeing the window of the software, I am focusing the sample. So you need to firstly we need to take our objective, means which objective we are using. Right now we are using 50x, so this one is 50x, right? And now you have to place your sample below your objective by this joystick. You can move it right, left, or front, or below, right? And just with the help of this knob you just focus your sample. So as you can see in our sample, a spot is coming, right? And now you can see in the software window, you can see the sample surface in the window. I need to fix a spot where the analysis is done, right? So I'm fixing this spot. After this, now we will going to analyze the sample. So as you see, our sample is there, and we have already focused the sample with the help of the joystick. The sample is totally focused now. So now giving the parameter 100, 1000, the range of the spectra, acquisition time. Basically you need to give the range only, range, acquisition time, accumulation time only, and which laser you are using, and if you need any filter or not. So I am giving the range, this acquisition time 10, accumulation time 2, and I am using 633 nanometer laser, and I am using no filter here, so 100% there, and whole as 100, right? By fixing this all parameter, now you need to stop all process. So initially it shows red. After stopping it will show as white. So now as you can see it is white. Now we just click on this tool as the start spectrum acquisition. So as soon as we click on this tool, the analysis will start automatically. It will first fix the spectra from we have given 100, so it will fix around 100 first. Now analysis is take place. So as you can see, the spectra is coming. As this one is silicon standard sample. It has two peak. Mainly more intense peak is near about 520 to 521, and one is coming in 300. So the first peak, as you can see, 300, and the graph is shows here is Raman shift versus intensity. So the x-axis indicate the Raman shift, the range we have taken 100 to 1000, and the y-axis indicate the intensity or counts. So as you can see, the main peak for the silicon is coming here, and it is in around 517.61. It's supposed to be in 521, but some shift is there. So before analysis, we can do one thing, that we can do this auto zero, move spectra to zero order. If we move spectra to zero order, and after we can perform this sample, then we will get the spectra on 521 nanometer. So here also you can see the time taken for the analysis. This is the acquisition, 79% acquisition have already been done, and the estimated time left is 34 seconds. That time depends on your acquisition time and accumulation time. Means you are doing a slow scan or faster scan. If you do a faster scan, then the time for the analysis will be very less, and if you are doing slow scan, then it will take some 5 to 6 minutes as per the as per your range. If you given a longer range, then it will take more time, right? So as we can see, the analysis have already done. So we get our spectra on 517 517 or 580 yeah 518.40 nanometer, right? Here you can see 518.40 nanometer, right? So this is our standard sample. Now we will perform our sample that we have with us. We will see how to prepare the samples for Raman analysis. Actually, you can do powder samples also and liquid samples also. For liquid samples, we have other kit. One kit is there. We need to take the liquid sample in a quartz cuvette. I can show you the cuvette. This is the quartz cuvette. You will fill up to here your sample, and it has the kit for analysis. Sample mounting table is there for this kind of liquid sample. So today we will do only the solid samples, means we have one powder sample with us, that is titanium oxide. So to mount the sample, we just need to get one glass slide, clean it with the acetone, take one spatula and clean it also. Take your sample in very small amount and place it in the middle of the slide. This is a very simple sample preparation method. Okay. Now place your sample below the objective. Set it. Set it with the help of this joystick. Then, as I say you earlier, you need to focus the sample with the help of this microscope. So for that we need to turn on this white light. Yeah. And with the help of this focusing tab, you have to focus the sample. As you can see in the software window, yeah, we see the sample. For better focusing, we will using 10x instead of 50x. After focusing your sample, we need to give the acquisition parameter. So I am giving the range here, same range, 100 to 1000. Yeah. Acquisition time as 6, accumulation time as 2, as I perform a slow scan, fast scanning. If we need to scan it for a faster, then we will give the acquisition time. We will have to increase the acquisition time, right? Then objective, I am using 10x objective. Grating is the same. Filter, I am using no filter, so 100%. Using 633 nanometer laser, and hole is as 100. So after setting this parameter, we need to stop this to initial our parameter. Yeah, or stop. Just place your cursor here and stop. So it turns as white. Now we can start our analysis. So start spectrum acquisition. So as you can see, one peak is already there at 139. nanometer approx, and one small peak is there at 193 nanometer. Yeah. So as you can see, the analysis is completed. Now we need to save the data. So for that, the same process is there, save as data. You need to click on that. This is save, right? So after complete the analysis, we need to turn the system off. For that, we have the process. First, we will have to go to the microscopic window. For that, we need to click that start video acquisition. Yeah. Now stop all the process that is running in your system. Yeah. And as I said in the starting that the detector is working in minus 60 degrees centigrade. The detector is cool now, so we need to click on this. We can found warm to ambient temperature, means it comes to room temperature. When it comes to room temperature, then only we can shut down our system. Before we cannot, right? So we need to click on warm to ambient temperature. Simultaneously, you need to turn off the light, that is the white light that you require for your sample focusing. So I am turning it off, and I am taking my samples back, right? And you do the cleaning method that is required. You just clean your sample mounting system if any dust is there or not. And the precaution you can take here, as it's all about the laser, so you need to save from it, right? And one thing is there, you need to be careful when you are using the you are shut down the software. As I say, the detector may get destroyed if you not warm it to ambient temperature, right? These two things, and you will have to 30 minutes to get the detector back to the room temperature. After that, you just switch off your software. First you just close your software first, and then one by one you need to close first the lasers, the controller of the laser. For that, the opposite process, you just turn it off, these lasers, and the laser controller for the 532 lasers. After turn off all the laser, you just need to switch the power button for lasers first, the controller for the microscope, and the main power button. Right. So this was all about Raman spectroscopy. Thank you.